Hello, welcome to Linux Skills Review. This video is prepared for WakeTech TLC North. In this uh, Linux Skills Review, we will have two parts. In the first part, I'll explain some of the concepts, and in the second part, I will demo the Linux commands possibly you will encounter in your exams and as well as in your future work. Okay? Um, let's look into the file system. So, operating system, one of the key uh, element of an operating system is file systems. So, operating system does many things, and it is the main thing is it provides the disk management through file system. Okay, so in Linux file system, it is something very similar like what we discussed in Windows. If you are, in case you've watched Windows Skills Review, it's very similar with subtle changes. So in like any file system, this is an hierarchical structure. Okay, and in this hierarchical structure, you'll have multiple levels, right? So at the topmost point, we have the great great grandparent or the parent of all the folders. It's called root. Okay, and in Linux and Unix, famously we call some of the users like the powerful user of that particular system we call root. So they will have a root user, and then it's impossible for you to get a root password. It means you can change anything in that. Okay, so this is root. Okay, this single slash, and then it has a child home, and then the home has your user name. So this is actually your home, right? So in the home, multiple users will have there, and each user use that directory as their home directory. Okay, and then your user directory has WakeTech, and WakeTech has a child courses, course has multiple child system and programming, so on and so forth. In this directory structure again, the directories are marked as green. Root also root directory, but it is something special. That's why we marked like the color of the root folder is orange, and the purple structures are nothing but simple files. Okay, one is a picture file, another one is a data, and another one is a text. We have multiple files like various kinds of file extensions you may get into. You might need to handle. Okay. All right. So in this file system, you might have noticed one interesting thing. It's very close to the natural tree, right? Tree is also one of the hierarchical things. You can see the tree has root, and then it has stem, and then it has various branches, and then they have leaves, right? So it's the same analogy here. But the interesting thing is this tree, normally tree, the root is bottom and then the branches and stem will go up. Here it's a upside down tree, it is, right? The root goes top like that, the root goes on the top, and then the leaves are nothing but our files, okay? Branches are nothing but our directories. So the idea is branches can contain another branch or leaves, right? But leaves cannot contain another leaf or branches. Okay, so similar concept here. So since it's an hierarchical relationship, right? The relationships are key here. We need to learn certain things. Based on the relationship, it behaves a little different, like the way we navigate in this structure. Okay, so we have like there is a parent-child relationship. So if you consider this as level 0, this is level 1, level 2, level 3, level 4, level 5, and all of these are level 6, and then the files are at level 7. Okay, If you go from one level to previous level, that means the previous level will be a parent. If you have a relationship, if you have a path, then they have a parent child relationship. In this case, we have courses as multiple children. One of the children is system, other child is programming, right? So so basically, so there is a parent-child relationship exists in the hierarchical structure. Likewise, if the folders are at the same level, that means they are siblings. In this case, I cannot show much in this program because of the place, but programming has 4 children, okay? So it's not very clear in this diagram, but you can see programming has Python, Java, C++, data. All are children of programming, right? It's not, this is completely disconnected. So system and programming are like parallel structures. Again, they are siblings. That's why they are parallel structures, okay? So all these things, like all these programming folders, Python, Java, C++, data, are all siblings, okay? Likewise, NAS 110 and CTA 120 are siblings and they are children of system parent, okay? All right, so okay, so let's discuss about the path, which is one of the key concept in operating system, in file system. Okay, so the most important thing is, like I mentioned in another video, building a path. So navigate yourself from one location, one directory to another directory is a key, because that's how you access the resources, either directory or file. And most of your commands, operands or arguments, are nothing but the files or directories. That's where you operate. Like basically you copy, you move, you rename, you change directory from one location to another location, so on and so forth. Okay, here there are 2 kinds of path in file system. One is an absolute path, and another one is relative path. So what do you mean by absolute path? Absolute path means for a given snapshot, if this is my file systems, basically this file system has no, like if I am not deleting or inserting any directories, it means the structure remains the same. If the structure remains the same, then the absolute path remains constant. Okay, so let's see how it remains constant. So the absolute path always starts from the same source, that is from your root. Okay, so from root, if there exists a path to your resource in file system, definitely it's, again, this is like a graph, right? Tree is also nothing but a graph. So there exists a path here, right? So it should always exist, because that's how we reach to our resources. So if you trace from your source root to wherever your destination goes, that's an absolute path. So in this case, I'm trying to create an absolute path from from root to file1 txt. Okay, so the dark red basically follows your absolute path. The key thing between Windows and Linux is basically all the directory separator is a /. Okay, in the case of this is Linux. In the case of Windows, it's a /. Okay, that's the only difference. Apart from that, the concepts are exactly the same. Okay, the Windows has a drive name, but in Linux, it is simply /. That's the root. Okay. So there is no like C drive, D drive, or something like that. It's all just like start from root. Okay, so here, so I go like basically I travel from root to home to your user home to WakeTech courses. From courses, I go to programming. From programming, I reach its child C++. C++ directory has file1.txt. Okay, so that's the absolute path for reaching file1.txt. So you can see that from root we trace, right? We trace that route, basically home, user, and you follow the path. Okay. Likewise, in relative path, it's a little different because in absolute path, why it is absolute is the source is always fixed. It always starts from root. But in the case of relative path, it's relative to my current directory. That is, my source location is my current directory. From my current directory, how can I navigate relation with my current directory? That's why it's called relative path. So a couple of key things we need to understand in relative path. Okay, so one is from my current directory, if I want to navigate to my parent directory, both in Linux and Windows, we use two dots. Okay, and then the two dots represents the parent directory of my current directory, and then the dot represents the current directory. Okay, so based on this, let's see an example. So I want to build a relative path from NAS 110 to table1.dat. Okay, table 1 is here. So table 1 is here, right? And then my NAS 110 is here. So how do I trace this relative path? So first thing is, again, they are parallel structure, right? They're kind of almost siblings to each other. So I cannot just like hop over. First thing first is I need to find a common parent. It's not in my same lineage here, right? So first I need to travel to NAS 110 parent. In this case, it's system. And then system, I need to go to courses. Okay. So there will not be any, actually, there's no courses here. Okay. So basically, that's the parent. Okay. So it goes to courses. And then courses is now a common parent here, right? It's basically, it is a parent of my two structure like siblings like system and programming. So from courses, I just hop to the other parallel structure programming, right? From programming, I come to data. From data, I reach table1.dat. Okay, sorry for this error. I'll just correct that. Okay, so that's the relative path. Okay, so when I move from my current directory to my parent directory, I use two dots. All right, so that ends the path concept. Now let's look into the Linux commands. Again, I will go through these commands in my demo video. So that's part 2. So you can see in action all these things. But here I'll just explain how they are, like basically what's some concepts behind it, but they're pretty straightforward. So in Linux, if you want to get the help for Linux any command, you can use man pages. Okay, try to read about man. This might be a good opportunity for you to read about man. Man is nothing but manuals. Okay, all right. And also, there are other ways you can get help. So in Linux or in Windows, it's always your command, okay, and then your path. That's how the format is always, okay. So if you want to cd, like change directory, and then you build a path. If you want to create directory, anything you operate, your arguments are most of the time it's path, because using the path only you can reach the resource. You operate always on the resources. Like resources are nothing but directories and files. So the first command what we are going to look here is how do I create directory in Linux operating system. So the command for that is make dir. So make dir, and then if you give the directory name, it'll create a directory from your current directory. Okay, in this video we are assuming that you are at your home directory. From your home you are creating wake So basically that's what the assumption is. This is your home. From your home you're creating wake directory. All the examples are based on this diagram, so pay attention to this diagram. You will get it. It'll be very clear for you if you're a visual learner. Okay, so make directories, like if you use multiple directories in one command, it'll create different like in the same hierarchy. It'll first create vectech. Inside the vectech, it'll create courses. What do I mean by that? Courses are child of vectech. Likewise, this will create programming. Programming will be a child of courses. Courses will be child of VTech. So this is the hierarchy it follows, right? They are separated by forward slash here. In Windows, it's backward. That's the only difference here. Other than that, the path concepts are exactly same. Okay. Sometimes this is a special command. I'll show in demo. You can just create everything using this minus "-p" option. Okay, I'll demo it. So in Linux, if you want to create file, the best way we do is using a touch command. You just create a blank file wherever you want to create. In this case, we are creating file1.txt. Again, it's relative to your current home directory. Okay, just make sure that you understand that. If I am not mentioning anything about a particular directory structure, that means you are at your home. From your home, you're creating, you're working on that. This is again the touch command. You're initiating this command from your home. Okay, I'll demo it. It'll be very clear. So the touch command basically creates file1.txt in C++ directory. The other way to create files is using echo. So echo will output whatever you're keying. Instead of outputting the sentence, you redirecting this content to go and write in a file stream, right? So it's create basically a file, and all these character streams are redirected to that file resource. Okay. Likewise, Unix has there are multiple editors. Like I always use Emacs. So Emacs is very complex, and there is a nano editor. So, but a very common text editor, most of the administrators they use, it's called VI. Emacs is mostly for the developers. I'm a programming guy, so I use Emacs, which has multiple. It's a very powerful editor. So VA is also very powerful, but it's more for like admin things. Okay, and it works closely with administrator. Most of the administrators are extremely well versed with the VA editor. Okay, so you can also create files using VA. Okay, and if you want to see the content of the file, you can use cat command. Of course, you can use VA Nano or Emacs editor to see the content of your file. Okay. Um, Changing directory. This is one of the things you will always use most of the time. So changing directory is like if you want to change to your parent, okay, this is a relative path, right? So whatever my current directory is, move from my current directory to my immediate parent, okay? If you are in your home, your immediate parent will be home directory, okay? Likewise, if you want to change to root, so wherever you are, if you just say cd slash, there is a space always, right? Here also there is a space. Cd slash, that will go to your root. You are somewhere and you want to go to your home drive. These are all the more common kind of cd command you will use, right? That's why I listed here. So if you say just cd or cd tilde, basically you will be taken to your home. Your home is nothing but, we already discussed, it's root and then common home folder, and this is your home, right? If my name is Shack, probably it's home, Shack is my home directory, okay? Just in case if you're not very clear about that. And then if you want to go any other desired location, all you need to do is cd and then you just build that path. The path can be a relative path or it can be an absolute path. All right. So one of the very useful commands we always use in command line is listing the directory, because I need to know what exactly is in my directory, right? So that's how I can look into that, browse my content, and then see whether my directory has another directory and so on and so forth. So this is one of the most important command, and it has so many options. Okay, so here I am just including some of the common options I use and most of the Linux users use, but there are like tons of combinations you can use here. Okay, so the plain one is just ls. If you just use ls, it'll list the directory in short format. Okay, if you use -l option, it will list the directory in long format. So in long format, I'll display in my demo, you will have the privileges also. You can see your privilege, like whether, like what kind of privilege the owner is set it for that particular resource. If you're in the group, or if you're the owner, or if you're the other users, how are you going to, like, whether you have a privilege to access those resources, what kind of privilege you get, all those information you can get it from long long format. Okay, apologize. So the other option here is, so there is an LRT. That means it lists the directory in long format, but also it's sorted based on the recent changes. Whichever the file you recently changed, that will be listed as the last, okay, in the descending order. So just in case if I'm expecting some log files or something, I want to see whether it is changed or not, or modified or not, I'll use this command. The other useful command is, there are not all files are visible. Some of them are system specific files. So it's hidden from the normal user. But If you're a power user, if you have enough privileges, you should be able to view those hidden files using an option A. So in this case, I'm saying show me the hidden files in the long format. So it shows all the files, including hidden files. Okay. Okay. Now let's discuss about the copy command. So this is one of the useful command. You will always use it. But whatever I'm listing here, all the commands are very useful. Okay. So here I want to copy my picture.jpg file to CTA 120. Okay. Again, I'm not saying from where. That means it's an absolute path. My source is always from root. Okay. So cp is the command, and first you build the source where my JPEG file is there. So it's you navigate, you traverse from home to user. That's your home, and then from there vector courses, programming data, and then you reach your resource. That's your source, and this is the destination where I want to copy that file. Okay. So how do you write like something similar, right? In this time, using a relative path, and currently I am in Python directory. Okay, so if you have difficulty in visualizing this, go and look at the picture again. Most all this is given as an handout in North Campus. I believe it will be available in other campus also. Okay, so have a copy of that and just try to use that document for your reference. So in this case, um, here your current directory is Python. Python and data are sibling, right? Again, I cannot jump directly from my sibling. I need to go to a common parent. In this case, my immediate parent programming directory is common parent for Python and data. Okay, so all I need to do is move to my immediate parent. This is my programming location. From programming, I go to data and then I retrieve my picture.jpg. Okay, and then I need to reach my destination. So again, remember it's in Python. So I need to move to programming. Again, programming is a parallel structure because CTA 120, it's in the other lineage, right? It's in the system. So I need to move up again. Then I reach courses. From courses is a common parent, right? It's a parent for system and as well as programming. So from courses, I move to system. From system, I move to CTA 120. That's the way we traverse in the relative path. Okay, I hope it's clear now. Okay, again I will try to demo it. That will even make it clear. If you're having any questions, try to go have the picture ready with you and then look at it. That will make everything clear for you, right? Linux. Okay, so suppose these are I'm copying files. How do I copy a directory? So in copying a directory, it's kind of a directory contains directory and then it contains files. So it's a kind of recursive structure. Okay, recursive structure, it's a mathematical thing. Recursion is a function, right? So if you're not very familiar with that, try to Google that and see what is recursion is. So we use recursion as a option here, right? And then we just use similar like files, but in this case uh, the resource is directory, not the file. So I'm copying data directory to webtech directory, right? I copy the entire data and its subdirectory to webtech directory. All right. So suppose I want to display my current directory. I can use this simple command password, present working directory, pwd, will show you where you're currently located. This is a handy thing. Sometimes when I want to build a path, instead of copying everything, I'll just put present working directory, copy that, and then build path from there instead of typing everything. Okay, it's again some tips and tricks here. If you want to rename your resources, you use command move. Okay, again, move, you need to say the source and destination, right? In this case, move can also be used for moving the resources from one location to another location, or it can be simply used to rename the resource name also. In this case, file name or directory name or anything. Okay. All right. So if you want to delete any content, you use a command remove, and then you give the path for that resource, whichever you want to delete. In this case, I'm trying to delete my picture.jpg, which is in data directory, right? And currently I'm in Python, so I'm giving a relative path to delete that file. Okay, to delete the directory, we have to do the same thing, but we used to use the recursive option. And also, one thing you need to note is if you have contents in your directory, Linux will not allow you to delete. So in those circumstances, you might need to use a force option. You might couple of options for you. Either you delete the all the contents and then you delete the directory, or you are very comfortable, then you can force it. Just say, I know what I'm doing. Just go and delete this directory and subdirectories. Okay. Again, when you are deleting anything, make sure you're careful, right? Be mindful and careful because sometimes it's irreversible. You will be in trouble. So if you want to clear the screen, you can use the clear command. There are other interesting things which I referred in Windows. It's the same here. Okay, there is a command called history. Okay, if you type history, it will show all the recent commands you used. Okay, you can just use up arrow or down arrow to browse your most recent commands. Okay, this is very useful for my like make it my life easier. And also the tab key can be used for auto completion. Okay, this up arrow and down arrow and tab keys are the real helpers for you. Okay, they are very resourceful. You should be like I always, because it's difficult to type everything correctly and you may make a typo, then you need to redo everything. So tab is um, your what you can say is a lifesaver. Okay. All right. Now let's discuss about another fundamental concepts, file permission, which is very important in Linux, okay, or in Unix environment. So we need to know a little bit deeper about that. Just in case if you watched my number systems video, right? I mentioned file system is one of the areas where we use binary system like bits. Okay, so Linux or Windows, I mean Linux and uses Unix uses 9 bits for setting up a file permissions or directory permission. Okay, so it comprises of like three. It's like three groups. Okay, so it's like 3 bits, 3 bits, like 3 bits. That's what this. That's what this RWX. I mean, there is a owner group, and then the other users. Okay, so all these three types, they have 3 bits for the location. Okay, so what it means is if I have something like 3 bits, for example, owner, right? If all the bits are set, that means the owner can it's like 7, right? How it is 7, please refer my number system video, but here I will quickly glance over that. This is 2 power 1, this is 2 power 2, right? So it's like 4 plus 2 plus 1, it is 7. Okay, please refer my video. Okay, I will go in extreme detail about this. So if it is 7, then I can read, write, and suppose if I have something like 1, 0, very clear. Just giving read. But if it is 0, that means I'm not giving, write is not allowed. You cannot write, but you can execute. I'm giving permission like that. So in this case, 5, you can see that I can read and execute. So again, this is 4, 4 plus 1 is 5. Okay, that's why it is read and execute. Likewise, mostly that's a weird combination, 1, 0, 1. So mostly it will be like 1, 0, 0 or 1, 1, 0, something like that. Mostly it will be like 1, 0, 0. 1, 0, 0 means 4. That means they can read, they cannot write, they cannot execute. Okay, that's what this table and then the bits are representing here. If you have any questions on this, and if you have difficulty in reading this, I highly recommend go through my number system videos. It has plenty of examples and it explains everything about the binary numbers. Alright, so here I give the command to change the file permissions, or it's called chmod. It's basically change modifier it is. It modifies the file permission. So here I'm saying chmod 744 myfile.txt. What it means, right? So first 7, that's owner, right? Owner can, excuse me, owner can read, write, execute, but the groups and the other users, that 4 can only read. They cannot write or execute. Okay, that's what the permission says. Okay, it's a very key thing. Will be always tested. People always struggle to understand this. So if you understand the bits and then how what each number represents, like bit representation actually refers, then you should be easily crack this thing. Okay, so many students really struggle that. If you have a good binary number knowledge, and that's it. Then it's like 3 bits. How the 3 bits are formatted, like in what way they are setting the bits, that will give you clear idea. Okay. And if you want to check the permit, like what is the file permission? Again, like I said in the previous listing command, if you use list in long format, it will show you um, the particular resource, whatever the resource in this file path, the file permission for that. Okay, we will see in the demo. The last but not least is the basic shell scripting. Okay. Shell scripting is generally, if you want to automate some complex task, you generally write a shell script. Okay, this is the most important tool for any administrator. Okay? So if you're a Linux admin or like Unix admin or database admin, any admin, they just write function scripts. Okay, in Linux, we write shell scripts because the shells are the way we interface with the operating system. In this case, one of the common shells we use is bash shell. So this is the shell I'm writing a script. So whenever I write a bash shell script, I start with pound, this is called shebang. People call shebang. Okay, so pound and in this example, I'm writing a simple shell script. Okay, it is start the shebang, right? Like in bash, and then the read is an inbuilt function. What it does is it reads the user input and then it stores that value, whatever the user gives, in this variable. Okay, when I'm saying read name, whatever the user types in, suppose they type shack, the name will get shack. Okay, and then again, I'm asking the user's age. I'm trying to be invading their privacy. It looks like so whatever the age they want to give, basically that number will be stored in age. And in this simple shell, what I'm trying to do is I'm just saying my name is, and then I use a name variable. In this case, this variable will be replaced to shack and my age. So I'm just showing. It's a very simple example. Okay, just shows how the variables are, um, what's a custom variable and also how you can get variables from the user. Okay, sometimes you can have multiple arguments in your shell, and then the arguments can also be read into the variable. Okay, again, those are all like you can check there, and it's again it's beyond the scope of this review. Okay, so how do you run your shell?